solution to one of the practice problems that I supplied you with, and kind of walk through the process a little bit more slowly in case it's confusing about what do we mean by method 1 and method 2 of contextualizing, and because it's a little difficult to work your way through this idea of contextualizing, but I'd say it's really important. So we're going to work through question 2 in this video. The question asks, what's the volume of a mole of raindrops? And we're told a raindrop is about 1/10 of a milliliter. Okay, fine. I think this camera's quite far out, so I'm going to focus in a little bit. There we go. All right, so this is going to be question 2. So to find the volume of a mole of raindrops, we're just going to start with 1 mole of raindrops. And then we're going to turn that unit of moles of raindrops into just a number of raindrops, which is to say 1 mole of raindrops is the same thing as 6.02 times 10 to the 23 raindrops. And that has the function of canceling out moles of raindrops. Now, I understand why that might seem like an unnecessary step. A mole literally means 6.02 times 10 to the 23. This is a habit I have, but I would encourage you to build it because often we're not going to be starting with exactly 1 mole. We'll be starting with 1/3 of a mole, or 0.075 of a mole, or 200 moles. So that number ends up mattering a little bit later on down the road. But you pick your poison. However, we weren't looking for a number of raindrops. We were looking for the volume of that many raindrops. So we're going to change this unit into a volume. And so we know that we can cancel out raindrops because we can turn them into milliliters, units of volume. That's 1 raindrop. And then we'll multiply these numbers across. Okay, so I've got 1 times, and I'll show you how I'm typing in this scientific notation here in case you're still a little confused about how that works. It's going to be 6.02, and I press my EXP button. You may have a slightly different button that does the same thing, but it's your scientific notation button, times 10 to the power of 23. And you literally don't have to write the power of, you don't have to write 10, just write the power itself, 23. And we'll multiply that by 0.1, and divide by 1 twice, which actually doesn't have any effect. And so actually we just reduce our Avogadro's number by 1 order of magnitude. I think it's 6.02 times 10 to the 22. Now we have units of milliliters. Okay. So it's kind of overexposed there, so I'm going to zoom in a little bit here. Okay. And, oh, I can see units of raindrops canceled out as well, leaving just units of milliliters. All right. Now, our goal is to contextualize, so we're going to use method 1 and method 2 to contextualize our numbers. Okay, so method 1. So this is where we're going to take this unit of milliliters and try and think of a way to turn it to maybe a bigger unit that it's a smaller number, because it's too big a number so to envision. So maybe we can think of a smaller number that's easier to envision. So what I'm going to do is I'm going to say, okay, 6.02 times 10 to the 22 mils. And I happen to know that I've got a water bottle here, and it's a 1-liter water bottle, as a lot of them are. And it's got 1,000 milliliters. I've scraped off most of the paint, but you can see that we were measuring in mils here originally. And there's 1,000 milliliters in a liter. So we're going to turn that into units of liters. 1 liter, 1,000 milliliters. And milliliters end up canceling out. And as a result, we're really just taking our number here and we're multiplying by 1, which doesn't change anything. And then we're going to divide it by 1,000, which gives you 6.02 times 10 to the power times 10 to the 19 liters. And it is a little smaller, but not much. It's still like quite hard for me to fathom how big this is. So what's the solution there? Well, what other kinds of units are there for volume? Like, I could turn to megaliters, but I don't really know what a megaliter really is. That is not like a piece of my vocabulary. I do, however, know, so I'm just going to label that. It was turning milliliters into liters. So I think I could go one step further. This would be fine. If this was your extent to which you could make that into a better, more sensible number, that's fine. But I think I can go one step further because I know that a lot of people use cubic meters to measure large volumes. And a cubic meter isn't that hard for me to visualize. Picture a meter stick, right? Let's think about this. Let's think about a meter cubed. Let's draw a little picture. Picture a meter stick lying on the ground. Okay? That's 1 meter. And picture another one at right angles. Okay, you've carved out a bit of space for yourself on the ground. And then there's another one that you're standing right up on top, right? So that's another 1 meter. We're going to make a cube out of that shape. How much space is that? Picture that for a second. How much space would that take up? How many water bottles, how many liters do you think you could fill inside there? The conversion of cubic length cubed to volume is quite lovely in metric. Works out quite nicely. It turns out there are 1,000 liters. You can fit 1,000 liters of water into that cubic meter that you made. So 1,000 milliliters is equal to 1 cubic meter. So I can go one stage further here. So that's our method 1. We've got 2 different conversions here. So I'm going to say, okay, well, I've got 6.02 times 10 to the 19 liters. And maybe I can convert it once more into something slightly bigger, which is a cubic meter. So we'll put a cubic meter here and the liters down here. And I know 1 cubic meter is equal to 6.02 times, it's equal to 1,000 liters. I don't know what I was thinking there. All right, we'll cancel out those liters and we'll multiply again. Again, we're just dividing by 1,000. Divide by 1,000. Okay, so we get 6.02. We never really changed the number of sig figs we have here because we're only really using defined values so far, and which we treat as having infinity sig figs. So actually, Avogadro's number, the one we began with, was the smallest number of sig figs we ever used, which is 3. So all of our numbers still have 3 sig figs, and that's cubic meters. And that's still really big. It's hard for me to envision, so I'm going to expand it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to count from the right here, so in 3s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then I'm going to count my ones, or my hundreds, I guess, thousands, millions, billions, trillions, quadrillions. This is like 60.2 quadrillion meters cubed. Okay, or cubic meters, which is not great. I still don't really know how big this is. Okay, so let's see if we can go a stage further. So for the next step, method 2, we're going to use some references. So I'm going to see if I can find a Wikipedia page for orders of magnitude and volume, and see if I can find a good reference for volume here. So I'm going to try to put my laptop right underneath here, so we're going to see if this works. I hope it does. And maybe we can, I better first take us off of exactly what we're being filmed here, otherwise we're going to get a feedback loop. All right, and so here we have the order of magnitude page for volume. And it goes up here, and we're measuring in some kind of unit, but we've got to make sure what we're measuring. Oh, it looks like we're measuring in cubic meters. Well, that's good, actually. We already converted into cubic meters. So we're really looking for something that's sort of on the order of 10 to the power of 16 cubic meters. So, okay, 10 to the power of 2 cubic meters, which is like a double-decker bus, and we want 10 to the power of 16-ish. So how big is this? Okay, Okay, 10 to the power 15. It looks like we jumped to 10 to the power 17. Okay, that's cool though. Here we go. 3.7 times 10 to the 15 is the volume of the Mediterranean Sea. And maybe you have a hard time picturing the Mediterranean Sea, but that's like below Europe, in between Europe and Africa. Okay, it's 3.7 times 10 to the 15, and the units are meters cubed. 3.7 times 10 to the 15 cubic meters. Is that right? 3.7 times 10 to the 15. And I usually like to choose a unit that's a little smaller, but it would work with larger ones. You just have a fraction of the volume of all of the oceans. But I think we're closer to a number of Mediterranean seas. So I'm going to have a larger multiple of this one. Okay, so let me just pull the camera picture back up so I can see. Okay, so I can't, while we're doing that, I can't actually see what you're seeing. So I hope everything there was on screen. So what we learned there is that the Mediterranean Sea, and we should always label what our reference value is. Mediterranean, spelling, question mark, Sea is approximately, I use a little squiggle there, it doesn't, C with an A, it's approximately equal to 3.7 times 10 to the 15 cubic meters. Okay, so I can take my value here, maybe I'll take this one, I'm going to convert it into how many Mediterranean seas we have. It says 6.02 times 10 to the 16 cubic meters. And I'm going to convert from cubic meters into Mediterranean seas. And I already wish I had left a little bit more space there. So I'm going to write a little small, I think. So I know that I want to cancel out meters cubed. And we're going to convert it into units of the Mediterranean Sea. So 1 Mediterranean Sea is equal to approximately 3.7 times 10 to the 15 cubic meters. Okay, and now when I do this multiplication, my meters cubed cancel out. And now I'm going to take my value, 6.02 times 10 to the 16, I'm going to divide it by 3.7 times 10 to the 15. It gives me 16. Okay. Interesting. So I get 16.27027027027 ... Mediterranean seas. I'm going to abbreviate it Med Seas. But how many sig figs do I round to? Well, this one had 3 sig figs, but this one only had 2. They couldn't report the volume of the Mediterranean Sea. Maybe we don't know it to 3 digits of significance. Why would we? It also changes all the time. But, like, this is not a value that we would be wise to invest a lot of energy into recording to many significant figures. So that means our answer should have 2 significant figures, the smallest number of sig figs in our multiplication problem. And so that means that, now at this stage in the game, I like to express it. So 1 mole of raindrops is approximately equal to 16 Mediterranean seas in volume. Okay, so you can imagine that in order to fill the Mediterranean Sea, and that means like in between Europe, this is that's Spain, this is an amazing drawing of Europe, there's Italy, and then there's Turkey, and then here's the Middle East, and then there's Egypt, and there's like pyramids here, and then there's Tunisia and Libya, Algeria, Morocco, and then the rest of Africa. Draw France up here, and then there's the UK. Maybe you recognize the UK. Anyway, this is the Mediterranean Sea. This is a Suez Canal, of course, here, which comes here. And there's Saudi Arabia. It's a Suez Canal, which you may learn about in socials. and this is the Mediterranean Sea. And if you have 16 times of that volume of all of the water in the Mediterranean Sea, all spanning all across Europe, that would be about 1 mole of raindrops. Okay, and that's how we can contextualize numbers. Now, this is not the solution. This is one way to contextualize this number. I chose meters cubed. Maybe you happen to know what a megaliter is. Power to you, and then maybe megaliters made more sense. Or maybe you didn't want to express it in terms of Mediterranean seas, but Black Seas or something else. That's fine too. There's many different ways to do this, and this is just one possible way to try to contextualize this number, and this helps me a little bit. I know that the Mediterranean Sea is a large volume, but like knowing that it's 16 of those volumes and not 10 trillion of those volumes helps me contextualize how big a mole is a little bit. And every time I do this, it helps me understand big numbers. All right, I hope that helped. Good luck with your poster, and let me know if you have trouble with this stuff.